Okay, so for this lecture I'm going to be doing a circuit problem, and the circuit problem objective is to find the node voltages of the circuit. This is the circuit that we have, and these are the node voltages. You have V1, V2, V3, and V4. Okay, so next, since all the resistors are of the same value, going back to the diagram, you can see here R1, R2, R3, R4, R5, R6. Since they are all of the same value, R1 equals R2 equals R3 equals R4 equals R5 equals R6 equals R. So notice that there is a supernode here. Okay, so with the resistors, I'm just going to be using R in place of all of the R's, okay, because of the value. And again, notice that there is a supernode. The supernode is right here from V1 to V3. You can see a supernode right there. So noticing that you have a supernode, the KVL constraint equation due to that supernode is V1 minus V3 equals Vs. Okay, so for our equation number 1, we have V1 equals Vs plus V3. So KCL at the supernode, we have V1 minus V2 over R plus V1 minus V4 over R plus V3 minus V2 over R plus V3 over R plus V3 minus V4 over R equals 0. Next, we have V1 over R plus V1 over R minus V2 over R minus V2 over R plus V3 over R plus V3 over R plus V3 over R minus V4 over R minus V4 over R equals 0. So after you simplify all of that, you end up with 2V1 over R minus 2V2 over R plus 3V3 over R minus 2V4 over R equals 0. And that's going to be your equation number 2. So next, moving on to KCL at V2. We have V2 minus V1 over R plus V2 over R plus V2 minus V3 over R equals 0. And then next we have negative V1 over R plus V2 over R plus V2 over R plus V2 over R minus V3 over R equals 0. And then finally, when we simplify that a little bit more, we have negative V1 over R plus 3V2 over R minus V3 over R equals 0. That's our equation number 3. So next we have KCL at V4. And so we have V4 minus V3 over R plus V4 minus V1 over R minus IS equals 0. So when we decompose that, that becomes a negative V1 over R minus V3 over R plus V4 over R plus V4 over R equals IS. And so simplifying that becomes negative V1 over R minus V3 over R plus 2V4 over R equals IS. That's going to be our equation number 4. So take notice of the fact that use of equation 1, which is our constraint equation, and equation 2, 3, and 4 will express these 3 equations in terms of 3 unknowns. With 3 equations and 3 unknowns, we can solve the system. So I'm going to take equation 1 and place it into equation 2. That gives us 2 times Vs plus V3 divided by R minus 2V2 divided by R plus 3V3 divided by R minus 2V4 divided by R equals 0. And so next we have 2Vs divided by R plus 2V3 divided by R minus 2V2 divided by R plus 3V3 divided by R minus 2V4 divided by R equals 0. Okay, so next we have negative 2 V2 divided by R plus 5 V3 divided by R minus 2 V4 divided by R equals negative 2 Vs over R. And so finally, when we simplify that a little bit more, we end up with negative 2 V2 plus 5 V3 minus 2 V4 equals negative 2 Vs. That's going to be our equation number 5. Then next we're going to take equation 1 and put it into equation 3. Then we have negative Vs plus V3 divided by R plus 3 V2 divided by R minus V3 divided by R equals 0. Then next we have negative Vs over R minus V3 over R plus 3 V2 divided by R minus V3 over R equals 0. And then next we have 3 V2 divided by R minus 2 V3 divided by R equals Vs divided by R. And then that gives us equation 6 when we simplify that, which is 3 V2 minus 2 V3 equals Vs. And so next we're going to put equation 1 into equation 4. And we have negative Vs plus V3 divided by R minus V3 divided by R plus 2 V4 divided by R equals Is. And then next we decompose that and we have negative Vs over R minus V3 over R minus V3 over R plus 2 V4 divided by R equals Is. And next we're going to simplify it some more and we have negative 2 V3 over R plus 2 V4 over R equals Is plus Vs over R. And then finally we have our simplification here for equation number 7, which is negative 2 V3 plus 2 V4 equals RIS plus Vs. So equations 5, 6, and 7 are in 3 unknowns, namely V2, V3, and V4. So the resulting system is that A equals the matrix here that you have, it's a 3 by 3 square matrix of negative 2, 5, negative 2, 3, negative 2, 0. Then the final row here is 0, negative 2, 2. And with Vs equal 12 and Is equal 10 milli, okay, so Vs is going to be 12 volts, Is is going to be 10 milliamps. Then that gives us our B column vector, which is going to be negative 24, 12, and 22. And then our voltage column vector is going to be V2, V3, and V4. So solving this system will give us AV equal B, which is the system equation, and using matrix algebra for that, V equals the inverse of A times B. And what we end up with is V2 equals 6.4 volts, V3 equals 3.6 volts, V4 equals 14.6 volts. And now, using equation number 1, we can find out V1, and V1 is equal to Vs plus V3, which equals 12 plus 3.6, which equals 15.6 volts. So that's the final answers for our problem here for V1, V2, V3, and V4. And when you simulate this, you should get these results that agree with the analysis that we just did with all of our matrix algebra. Okay, so again here V1 is 15.6, V2 is 6.4, V3 is 3.6, V4 is 14.6, and that all agrees with what we got in our analysis here. So that is it. That is all that I have in this lecture. Hopefully it was helpful for you. Thank you for watching, and have a nice day.